Q2 is going to want to do something to it. It'll either want to speed it up this way or push it away the other way. And Q3 is the same thing. So it's going, both this charge and that charge are going to give this charge some potential energy. So it's going to either give it some lift or try and push it away, give it some speed. So it'll either give it potential energy or kinetic energy. We're just looking for the potential energy. So in this situation, we get Q1 right here, and we're trying to figure out what the potential energy is here from this one, and then what's the potential energy here from that one, the interaction between those two. So potential energy from those two, and then potential energy from those two. Okay, so we'll call it a PE2 and PE3 again. Similar sort of way to what we did before. So potential energy, 1, we won't call it 1, we'll call it 2, is due to Q2. And the potential energy 3 is due to Q3. This isn't a vector, so you don't have to worry about direction at all. You have to worry about sign. So we're going to calculate the potential energy here due to this one, and it will have a negative sign in it. It's not a vector. You're not worried about is it going left or right. You're just worried about number. Okay. So because potential energy is not a vector, you have to figure in the sign. You have to include it. So here we go. Potential energy 2 is equal to K Q1 Q2. Just divide by D. And then potential energy 3 is K Q1 Q3 divided by that other distance. I'll call this one D2. I'll call this one D3. Because D2 is that distance, and D3 is the distance between Q1 and Q3. So it's going to be the 6 centimeters. Okay, so those are the formulas you would use. One's going to turn out to be negative, one will turn out to be positive, then you just add the two. Okay? So that's what we'll do on the other board right now. You guys can move ahead if you want. Okay, so those two formulas I'll just rewrite up here, and we'll bring away. Q1 again? Was it 2? What's Q1? 3. Thanks. And Q2, was it -2? Is it? Yes? No? Yeah?
Yeah.
Okay. -2? You got to put the negative in when it's a non-vector, okay, when it's a scalar. So this time we have to put the negative in. And the distance was 2 centimeters. So 2 times 10 to the -2 squared. I'm just getting rid of some sig figs to save some space. Not squared, right? It's not a D squared. Thanks. Good point. And then you'll get an answer. It'll be negative. Just let me know when you get it. Oh, sorry? 2.7? Thanks. 2.7, it's an energy. What is it? What are the units?
Units.
It's an energy.
Joules.
Joules, right? Joules. Okay, potential energy 3. This one will be positive. I don't know what it is though. What do you guys get?
Yeah, I got 2.7.
2.7 again. Really? So who got 2.7 again? Just by total fluke. Wow. Okay. We got a problem? Or do we have a problem? What's the total potential energy then that they give to Q1?
Yeah.
So the total potential energy at Q1 due to Q2 and Q3 is just add them right up. Minus 2.7 plus 2.7, which equals 0 joules. So it didn't, in the end, get anything from it.